next part of the lesson we need to talk about, because we wanted to prove it continuous and differentiable. So we need to talk about why it wouldn't be differentiable. And there are 4 reasons for differentiability to fail. Okay, the first one was the one that we just addressed. It's lack of continuity. Graphically, what that would look like is, let's just say we had something that went like that. And let's just say we had a open circle here and a closed. So that's just a jump discontinuity. Basically, your pencil had to leave the paper when you're graphing the function. Okay, the next type is a cusp. Okay, and graphically, what that looks like for your f of x is it's going to come down and then it's going to bounce back up. Okay, what happens is the limit as x approaches infinity of your derivative, which is talking about the slope, is negative on one side as x approaches positive infinity, and the limit as x approaches, let's say this is infinity to the left, as x approaches infinity to the right of the function. Okay, so here I was approaching negative infinity, here I was approaching positive infinity. So my slope was very, very, very negative, and then it became very, very, very positive. Okay, the way that the f prime would look, if I was going to graph that, it would look like that. Okay, but the original function, it looks like this kind of crevice between 2 hills. Okay, and they're approaching different infinities. Okay, your third reason to fail is a corner on your original function. A corner pretty much looks just like what it sounds like. Okay, but notice I'm not getting steeper and steeper and steeper. I've got a constant slope on one side, constant slope on the left, and a constant slope on the right. So the limit as x approaches infinity from the left of my function is equal to negative b, and then, or a negative slope. Let's just say b, because b can be defined as negative or positive. So it's equal to a finite value. And the limit as x approaches infinity to the right I am giving you wrong information here. Let me go back and fix this. I'm going to fix this and fix this. This is a, not negative infinity. That's a. I'm going to call that a. Again, apologize. It's easier to do this when I'm in class because you guys will catch my mistakes. And then this is as I'm approaching a again. And as I'm approaching a from the left and a from the right. Okay, so, and then fx is equal to c, where b does not equal c. Different finite values. All right, and the fourth reason for differentiability to fail is called a vertical tangent. Graphically, what it's going to look like on your original function, vertical tangent, I'm approaching something like that, and then pick it back up. Okay, so my differentiability is going to fail at A because my limit as x approaches A from the left of my function equals positive or negative infinity, and the limit as x approaches A from the right of my function also approaches positive or negative infinity. Notice this is a very positive slope and this is a very positive slope. The derivative function, and we're going to deal with graphing derivative functions, just so you know your derivative function, that would look like this. They're both approaching very, very positive slopes. So those are your four reasons for a differentiable function to not be differentiable at a point. To give you some examples, if I have f of x is equal to x to the 2/3, f prime of x is going to be 2/3 x to the negative 1/3, which is 2 over 3 cube root of x. Okay, as you approach, as x approaches 0, I'm going to approach different infinities. One is positive and one is negative, so that's going to create a cusp. And I would encourage you to put this into your calculator and see what it looks like. You'll see what the cusp looks like. Now, if I tried f of x equals x to the 1/3, my f prime of x is going to be 1/3 x to the negative 2/3, which is 1 over 3 cube root of x squared. Well, this is going to be always positive, so it's going to be same infinities. As you approach 0, so it's going to be a vertical tangent. And did I really do that?